So this podcast is called From a Ratio into an Angle. Remember when we were doing this nice little triangle here and we said, oh, okay, there's my nice little 90 degrees, and I put my eyeballs down and I said, there's the hypotenuse. And if I said this was, let's say, angle, oh, I don't know, angle A, and then I said, all right, there's my nice little eyeballs, and it's staring at the opposite, and the adjacent is the last one to be written out here, and that's how it is. Okay, well, all right, fine. Look at the first question that we have here, and let me show you how to do this. What I did before is I always gave you this. I always set you up with this. But I never said, how do you find the actual angle now? That's the question. So if you look at this particular reference that I've got here, this is the angle that's in question. That's the guy we want to try to find. But we know that this top one is opposite. We know that the bottom one is adjacent. Why? TOA. Remember? TOA, opposite over adjacent. So this in fact is 3, that in fact is 4. How do we find this angle? Well, that's where this guy right here comes into play, tan to the minus 1, because I want to show you how this works. Right now we're sitting at tan of the angle A equals to 3/4. All right, so we got to get rid of tan somehow. Well, yeah, we're going to use something that we've used 1,000 times over, algebra. And the algebra for this is very, very easy, but it's important to see. As you know with algebra, in order to solve something, you kind of do the opposite of what it says in the question. What do I mean by that? Check this out. 2x equals to 6, right? You know and I know that means times. Algebra tells you get rid of it by doing the opposite. Yep, and what you do to one side, you do to the other. So look, I'm doing the opposite. To get rid of this, we've got x equals to 3. Why? Because I want to isolate x. I want to know what x equals to. Take a look again. What if I gave you x squared equals to something like 16? Well, what is the opposite of this guy? The opposite, of course, is to square root it. The square root of x squared just gives you x. What you do to the left side, you do to the right, you got 4. So notice how we're doing the opposite all the time. Well, tan has its opposite as well. Tan's opposite is tan to the minus 1. And like before, what you do to the left, you have to do to the right as well. And I'm just going to put this in brackets because I know that all my fractions will have to go into brackets eventually when I use my calculator. So wait a second. What does this imply? Well, look, like this, where that cancel, right? And the squared and the square root cancel just to give us x by itself. A is just a variable like x, right? So you can actually, instead of having tan A there, you can have x, and we're solving for x. But check this out. Tan and tan minus 1 are opposites of each other, so they cancel out. See that? Leaving you the a or x or whatever you want to do, whatever variable you want to use, leave that behind. So what does this mean? A equals to the inverse, right, of 3/4. Well, how do I do the inverse of 3/4? Simple. All you need is your lovely little calculator. Okay? First things first, check out, make sure it's in degree mode, hit mode, and sure enough, this one is in degree. You can see it blinking right here. Look, I'll show you. Oh, right there, it's blinking in degrees, so you're good. How do you get out of this mode? Real simple. Hit second and the mode button again, because right above it gives you quit. Now, how do you do this? How do you find tan to the minus 1? Tan to the minus 1, if you notice the tan button, right above it is tan to the minus 1. There you go. Now, how do you access tan to the minus 1? Well, it's in blue, so you use the second button to access tan to the minus 1. Okay, so let me clear this out of here, and let's use our tan to the minus 1 button and see what we can do. Okay, so second tan, there it is, of 3 divided by 4 bracket. Okay, and I like to finish off the bracket and hit enter. What does this mean? The angle is 36.86989765 degrees. Well, you know what? Depending on the question, listen to what the question says. If the question says to the nearest decimal place, okay, to the nearest ones, or to the nearest degree, or to the nearest tenth, whatever it tells you to do, that's how you answer the question. I'm going to say for right now, just to keep it simple, let's go to the nearest degree. So this, in fact, this 36.86 is actually 37 degrees. Now, what does that mean? That means this angle right here is 37 degrees. Let me write out this triangle again so that you can see it. The triangle, if you remember, was this one going to here, going to here. We said this was 3, that was 4. There's our 90 degree. That was our angle in question. Okay? We said that angle in question, because we calculated it out, was right here, 37 degrees. That ratio of 3/4, because we use tangent, we can now figure out the angle to be 37 degrees. And that's really, really important to us, okay? So now we know how to figure out the angles. Let's start looking at the rest of this table, and it should all kind of summarize really, really quickly for you once you get into kind of the habit of knowing when to do tan minus 1 and when not to. Okay, let's go to the next one. Question tan B, which is the second one here. Let me erase this and get it out of the road. Okay, everything's nice and clean. Let's go to tan B. Okay, here we go. Tan B. If you look, tan B equals to 7/4. We want to get rid of the tan. So what you do to one side, you do to the other. Okay, that cancels with that, leaving you B behind. Okay. So tan of the minus 1 of 7/4. So let's bring up our calculator, clear it, get rid of this guy too. Okay, so here we go. Second tan of 7 divided by 4, bracket, enter, and look at that. You get 60.255. Let's make this to 1/10 of a degree. So this would be 60.3 rounding degrees. There you go. So 60.3, there she be. Okay? And that's the relationship. All right, so let's go to tan C now. Same thing as before. Look at this. All I have to do is do exactly the same as before. Just remember the tan minus 1 button, and this should all work out really, really easily for you. So tan C is 0.5095. Okay, so tan minus 1 to both sides. Here it comes. Okay, so calculator handy. There it is. Okay, let's clear this guy out. Second tan minus 1 to 0.50. Come on, 0. There you go. 95. There it is. I like to close the brackets and hit enter, and you find that this is 26.9988 degrees. So let's say 27 degrees is close enough. 27 degrees if this says rounding to the nearest degree, okay? And for the most part, you're going to be asked to round to the nearest degree. Again, read the question. See if you can do this one on your own. Put the podcast on pause right now. I'm going to just go out and boot up the calculator. I'm going to show you the tan D one right now. Okay, are you ready? I've got it in my calculator. I hope you do too. Hit enter. I got 28.999 degrees. 29 degrees, close enough. I hope you got that as well. 29 degrees. Let's do the last one. Notice this kind of weirdness here. That little circle with a line through it. It's actually a Greek letter called theta. Okay? That's the Greek letter called theta. And that angle, they don't like using A, B, C, D very much. They like using these Greek letters because those Greek letters refer to actual angles. Okay? Other letters kind of tell you about side lengths and stuff like that. So as soon as you see this, you know you're dealing with an angle. It doesn't matter. It's a variable. It could be an X, it could be a Y, it could be an isomeria, it could be a theta. Who cares? You know and I know you have to use the tan minus 1 here to figure this guy out. So let's boot up the calculator. Second tan, okay, of 1.4653. Close the bracket, hit enter, and look at that. I got 55.7 degrees. 55.7 degrees, or if you want to the nearest, 58 degrees. There you go. But what I want to show you something is this. Look how these ones start. For example, you know that 3/4 is 0.75. Look what happens. Okay? As you're going here, do you notice a pattern? As your numbers are getting bigger, so are your angles. See that? See that? See, this is a bigger angle. This is about 1 point something, okay? As your angles start getting bigger, or as these ratios start getting bigger, this means the angles are getting bigger. Why? Well, take a look at this. Look at our nice little triangle again. If this angle gets bigger, that means the opposite side, of course, has to get longer. See what I mean? Look at it. Your opposite side's getting longer, but this is staying the same. So your opposite over your adjacent, since the opposite side is getting longer, means, guess what? The tan of that angle is actually getting bigger, right? So that's kind of important. But I also want you to go and see if you can draw some of these triangles. I want to specifically concentrate on this one for a second, okay? So I want to look at tan. Oh, it's not letting me extend the page here. There we go. Let's look specifically at tan of C, which is 0.5095. I want to draw this triangle. Well, this makes it really, really tough because with this particular one, if you put 0.5095 into a calculator, it's really, really difficult to make this into a ratio, into a fraction. Okay, decimals are really tough to put into fractions. So what I'm going to do here is I'm just going to go to 2 decimal places on this one. I'm going to go to here. So this actually works out to be 0.51. Now, if you're going to put this into a fractional form, you have to remember that this is the tenths, this is the hundredths. So I'm looking at 51 over 100. Now, remember, what does that mean? Well, that means that's what tan C was. Tan C was approximately 51 over 100. Why approximately? Well, remember, I rounded. Okay? So what does this mean? This means that this is the opposite, this is our adjacent. And check this out. You can now draw an approximate triangle that looks like it. There's our 90 degrees. There's our C. Perfect. So that's my angle in question. My angle in question was 27 degrees. There's my 27 degrees. There's my hypotenuse, which I don't care about, but right now there's my opposite. My opposite is 51, and my adjacent is 100. So you can actually draw from this ratio a beautiful triangle. So watch this podcast a couple times. I know it's a long podcast, but watch it a couple times so you really know how to do the tan minus 1 function on your calculator.